I'm not saying I'm not going to 2017. All I'm saying is we're starting with 2013. So you guys need to be ready with an FRQ and a part. Anybody have questions on number 3, 2013? Riley. A. Any other questions on 2013? B. Any other questions? Okay, perfect. Well, trying to do as much as I can. Okay, for number 3, scene. Water, reservoir, time. Okay, we all have things we need to be doing. Okay, water in a reservoir. They've given us selected values of W prime, which is the rate at which the water is something. Volume of water in a reservoir. Is it evaporating? Sampled. Huh. I don't know. Well, it's positive, so somehow it's increasing. So somehow the water in the reservoir is increasing, so it's coming from somewhere. They just haven't really given us much information. Okay, 0 to 30, and we know at 30. Hey guys, this is an initial condition, right? Cool. So I can say, if this is W prime, I can say W of 30 is equal to 125 gigaliters. Okay. Riley, the first thing you see on A, hopefully, is tangent line, right? Cool. Tell me a tangent line equation. Okay, now it's your job to take this general form and apply it. So in this application, we could say y of t minus y of 30 is equal, W, is equal to W prime of 30 times t minus 30. Does that make sense? Cool. So at this point, we can go ahead and, you could have just put W. You didn't have to put W of t. I mean, I like W of t because it's nicer, but W would have been fine. We know W of 30 is 125. So I do W of t minus 125 is equal to W prime of 30 from the table, is 0.5. Now, why am I going to leave the t blank? It says to use the tangent line approximation. I've made the tangent line. I've made it at 30 to predict W of t when t equals 32. So the idea is that I can use this equation, and technically if you want to keep it separate, it's probably a good idea. I can find this y value at 32, and the y value at 32, which is the tangent line, will give me the approximation that they're asking for. So I have 0.5, 32 minus 30. Everyone, eyes on me. What do you do now?
Just box it.
Box it and be done. Wait. W is what? Now box it. And be done. Bless you. Now box it and be done. Is that okay? Yeah. But everything else. Because the check meant good job. Oh, yeah, it was one of those. Okay, letter B. Left Riemann sum. Let me go ahead and quickly get a little picture of it. That way I can look at the table while I do it. Because otherwise it's too off the page. There we go. Use a left Riemann sum with 3 subintervals indicated by the table above. So wait, 3 subintervals, doesn't that mean like 3 jumps? Are there 3 jumps? 1, 2, 3. How do I do Riemann sums? Bases times heights. How do I get bases? Change in x's or t's in this problem. How do I do heights? The y's, the heights. Now it says left, so when I this jump, this first one, what's my jump? 10. So I can do 10 base times, which height am I using? Left. Next jump, 12. But I'm using the height on the left. Next jump, 8. But I'm using the height on the left. Now pause. It said use the left Riemann sum. Okay, hold on. I have the left Riemann sum. Okay, there's my left Riemann sum. to approximate 0 to 30. Okay, to approximate, right? W prime of t dt in an integral from 0 to 30. Okay, fine. Approximate, sure. Whether or not you knew it, you can be like, okay, it is. Right? I mean, just steal. Use this approximation to estimate the volume of water WT in a reservoir at 0. At 0? I think they want a final given an initial. Oh. Isn't this integration as net change? Set up your formula, set up your formula, set up your formula. Right? Final equals initial, that's one way of doing it, plus 30 to 0. Now some of you are like, ew, gross, I don't like 30 to 0. Okay, then change it. Where could your 30 be? On the other side, right? So why don't we go from 0 to 30? There's our 0. There's our 30. We could do that. That's all right. No big deal. So I know that W of 30 is, uh-oh, I can't see it. Do you guys got it? 125? Not W prime, W. 125. W of 0, I have no clue. My approximate? Oh. Well, I don't have this guy, but I do have this guy, so can't I write him down? So I can say, well, hold on, pause. As soon as I put the Riemann sum in, it's no longer equals. Now it's approximate. Now it's approximate because I'm not solving exactly. I'm using my Riemann sum. Then I can do my 10 times 0.6 plus 12 times 0.7 plus 8 times 1.0. How do I solve? Subtract. So what does W of 0 equal? Well, 125 minus all of that. Yes. So what am I going to do? Yes. W of 0 is approximately 125 minus, now careful, don't let them take away the point. You have to subtract the whole thing. You can't just put a minus and then put all of that. You need to put a minus with a parenthesis or a minus, minus, minus. Because you have to subtract the whole thing. But as long as you put the subtraction or the expression in parentheses, or as long as you do minus on everybody, now you're good. I have to subtract the whole thing. Wait. Exactly. W is measured in what? Gigaliters. Dun, 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 dun. Okay. Any other questions on number 3 going once? Going twice? Number 4. 2013 number 4. Anything? When you see limits to infinity of exponentials, you think they're trying to trick you. When you see limits to infinity, which can happen with horizontal asymptotes, or it can just happen with limits to infinity, and exponentials, they're trying to trick you. Because if you go to positive infinity, what's this guy alone? What's he going towards? There he is, right? He's up there. But what's the dilemma if I'm going to negative infinity? Oh, it's a negative power. What's going on with negative powers? It's 1 over. Ah! If it's 1 over, who wins? Bottom wins. It's to infinity. Horizontal asymptotes. My ones that are looking for little tricks that they're trying to see. This is 1. Limits to infinity are horizontal asymptotes with exponentials. They behave differently based on the direction. Sorry. Number 4, questions. Ashley, go. C. You guys have the function to keep me honest? Actually, let me just do this. It's easier. It's faster. Here we go. C. Find the intervals on which f is, someone tell me something about concave down. That's the second derivative. Second derivative is negative. Second derivative is negative. Well, don't you need the second derivative first? Okay, not calculated problem, can't use that. Here we go. F double prime, nope, I can't get to F double prime until I get to F prime. I'm guessing you might have done F prime earlier in the problem. Did you? No. Oh, really? Oh, that's fun.
The one we did with the minus x approaches.
Second? D first? Plus? Oh, okay. Double check. Does that look good? Okay. You have some options. You could just take the derivative as is. Can I just be me for a second to make it go faster? Can I factor out the e to the x? That's in both. And can I say x squared plus no x squared is cool? Negative 2x plus 2x? Cool. Negative 2 minus 1 is negative 3. Sorry, I just didn't want to do two product rules. So f double prime. Second. D first plus first. D second. Find some zeros or D and E's for my pips. How about factoring? Because then, what can I do with that polynomial expression? Nope. Oh yeah, except I need to have the 1. Yeah, I don't know where I was going with that. What am I trying to do? Set equal to 0 to find my pips. Once I set equal to 0 to find my pips, e to the x can never equal 0 because ln of 0 does not exist. So you always ignore any exponentials when trying to find zeros. But I can say x is equal to negative 3 and 1. Now pause. They don't give me any sort of weird domain-y thing, do they? Like only these x's? No, I don't see any domain-y things either. Okay. So I'm going to go ahead and put my negative 3, put my 1, put my f double prime, put my f. If I plug into my second derivative, the nice factored one, e to the will always be positive, so forget him. But if I plug in negative 4, that's a negative, that's a negative. What's a negative times a negative? If I plug in 0, that's a positive and a negative. If I plug in 2, that's a positive. Where's my concave down portion? So steal the wording. The wording says the graph of f is concave down. Fine. The graph of f, steal it. They liked the wording, so they'll hopefully like yours too. The graph of f is concave down. Yes, they get C. On x within, it is an x, right? Good. Negative 3 to 1, since f double prime of x is less than 0 on that interval. Maggie.
So they won't care if we do bracket of x's.
Yes. That might lose you one question on the entire exam if you just always do parentheses. The one time that you wouldn't is if you're looking at a graph, and if an endpoint already starts below, like for a graph of a derivative, then technically at that endpoint would be included since you would have a negative there. But then anytime you have a 0, always open. Yeah. We're technically doing 2013 since there are no videos on it. Because you're leaving how early?
I'm leaving at like
30. Okay. So give me a second. If I haven't gotten there by like 35, let me know. Let me go ahead and come back, zoop, zoop, and let me go ahead and zoop, zoop. And then anything else on number 4? Okay, 2013 number 5. Okay. P.S. P.S. At the end of period 1 today, I had this whole little group of kids that were like, I don't get any of them. And they were like, oh, I get it. And that was these questions.
oh no.
Pause. Let's give it a name. Let's give it a name. Sometimes you just have to give something a name and then call it out. Okay? This is called what kind of function? Anybody remember?
Definite. Piecewise. Is it a piecewise?
Starts with an A. Accumulator. Accumulator. Okay. Okay. We talked about the name, but it's okay. It's not a forever card. It's a type of problem. G is the accumulator function of f of t. Accumulator meaning -2 to -2 to 3, -2 to 4, -2 to -5, it's accumulating area from -2 to somewhere. Why am I saying area? Because an integral denotes area under a function, right? Okay, so for g of -6, guys, you're making it too hard. Isn't that g of x? That's g of x when x is -6. So all I have to do for g of -6 is say, hey, where's the x in the equation? Oh, it's right there. 2 to -6 of f of t dt.
Are you kidding me?
It's the x. It goes in the x spot. It's okay. Got it. Now pause. 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 People got that and still missed it. So hold on. You're starting at -2, and where are you going? So this is the area that you're trying to find. Now, isn't that area just 1/2 base times height, and the base is going to be 4, and the height is going to be 5? Now pause. Why am I putting a big old negative? You're going backwards. So it's opposite the natural sign that it would have. Now you could flip the bounds. You could do it -6 to -2 with a negative, which would be negative of the positive. Area denotes displacement, and displacement can be to the left or to the right. So remember, if you have area above, it's naturally positive. Area below is naturally negative, but if you're going backwards, you flip the sign. So, would I simplify? No! Don't let them steal the points! Now, that's not the only one, so Riley, you tell me, how do I do g of 3? Got it? What do you do?
Have to add the area of the semicircle and the little triangle.
Good. So how do I do this circle?
R is 4. 1, 2.
Because diameter, yeah. And then, when I go to do the triangle, what's the area of a triangle? Why am I putting a negative? It's below. So I am adding the areas together, but one's above, one's below. I'm moving the normal direction. My base is going to be 1, and my height's going to be 2.
You were just making the point that the triangle area should be negative, but the circle is half, the semicircle is halfway across.
But we're looking at above and below. So we're going from -2 in a normal direction, from -2 to 6. So since we're going this direction, we keep the above positive and the below negative. So it's not left right, it's above below.
But the triangle's above.
Triangle's below.
The other triangle.
Oh, but I'm going backwards. And so the bounds need to be from A to B. If the bounds are from B to A, the property of integrals say that we would need to flip the sign to go the right direction. So, you don't give area, just based on the picture, you don't give area a positive or negative sign based on whether it's here or here of the axis. You give area, or you keep area the same, what it should be, or opposite what it should be based on from the beginning point, from the bound, if your bounds go the right way from -2 to 3, or whether the bounds go the wrong way from -2 to 6. So it's the bounds, not the picture, the bounds. Okay. Anything else in number 5? Okay. No. The accumulator function, period 1, needed me to go through the whole thing. So g prime of 0. Let me go ahead and get a picture of this so I can just have it up the whole time. Thank you. I don't know why I'm faking the computer, but it's okay. Kiddos, the accumulator function. Let me write it real quick. G of x is equal to the integral from, is it -2? Okay, focus in. This is an important concept. It'll definitely be on the AP, maybe an FRQ, maybe multiple choice. Okay, here we go. If I have an accumulator function and they want a derivative, I need to take the derivative. So if I take the derivative of g, don't I have to take the derivative of what g equals? Forever card. Who is this guy? FTC part 2. F of u times u prime. So g prime, the derivative of g, is equal to f of x. F of u times u prime is 1. Oh, and I just need it at 0. So if I plug in g prime of 0 equals f of 0, oh, I have a graph of f. F of 0, isn't that just the y value? Oh, what'd you do wrong? The derivative of -2 would be 0. The other one would have an x, and then you would plug in 0, so it would stay. Yeah. Okay. Now, hold on. Are we just going to C? I don't mind.
Sure.
If we go to C, horizontal tangent. Hold on. I don't want to waste your time. Anybody have a question on C? Okay. So for C, it says horizontal tangent. Kiddos, use focus. Use what you know. Focus. Horizontal tangent. Tell me what that means. Horizontal tangent. The slope is 0. And slope of g, what doesn't that mean? G prime equals 0? Now, careful. They can't give you points for stuff outside the box. It needs to be inside. Didn't you read the little note? Do not write beyond this border. Anyway, coming back. Coming back. I mean, unless you want them to ignore it. And it's like some of your mental math that you don't want them to see in case you did it wrong. That's okay. Coming back. Okay. G prime of x equals 0 at x equals -6, -2, 2. Sad that I haven't memorized. BC and AB asked about it. Why do I have to cross off -6? Says to not include -6. Now, how did I get these 3? Because those are the places where f hits y equals 0. AKA, those are the zeros or the x-intercepts of f. Because who is g prime? Now pause. What's going on at x equals -2? Local max, local min, or neither? I'm looking, but careful. Sharp points are legal for maxes, mins. Now, pause real quick though. The sharp point actually only makes a difference for the second derivative because the sharp point of a derivative graph points to the derivative's derivative. We're looking at the above and below because we're looking at g primes, f's signs. So the above and below. What's the sign of f for -2? Positive because it's above. What's the sign? So was there a sign change?
No.
Neither, since f has no, and I said f is g prime, sign change at that point. Okay, start thinking about 2 though. There is a local or relative because before 2 I have above, after 2 I have below. So I can say that there is a relative or a local max since f changes from positive to at that point. Sure. Okay? So how about letter D where it suddenly says points of inflection? Points of inflection, it's a forever card, right? You can as long as you know what you're looking for. Can I be cool and snazzy and a little nerd up here? Points of inflection. Put up my glasses. Points of inflection occur, just state the forever card. Be nerdy like that. You're supposed to have them memorized. Points of inflection occur when G double prime, because that's the guy whose points of inflection I'm looking. What's supposed to happen? No. Those are pips. Actual inflection points. Changes, well, you could say G's concavity changes. Or you could say prime changes. Doesn't G double prime Signs show concavity?
Yes.
Changes signs at zeros, right? Or DNEs of G double prime. Which, look, I just stated my forever card, basically. Then what am I going to do? Which occur at. Look, I already have my point for my justification, and I haven't even thought about the answers yet. Where will G double primes signs, wait, who is G double prime? G is the accumulator. G prime is equal to F. Who's G double prime? Take the derivative. Oh, so I'm looking where F prime changes signs? Well, F prime, isn't that the slopes of F? Well, where do the slopes change? Well, positive, negative, oh, sharp point. And second derivative sharp point where the slopes change signs. That's 1, -4. That's another one, -2. That's another one, 0. Where the slopes change signs. Now, this is on the video. You can check it out for a little bit longer. Cassette, you wanted me to go peek at the 2017, and you have a couple minutes, so what's up? Which one?
It was the penguin one on 27.
Is that number 2?
Oh,
Number 4?
2013, sorry.
Oh, it is 2013.
It is 2013.
Which one's the penguin one?
Oh, I did the penguin one.
Number 2?
Is that calculator one? Yeah, there.
D?
Yeah, that one. Number 2.
Which part?
The first one.
Oh, well, rate of change of penguin, this is how fast they're being born. That's how fast they're dying. So if you want the how fast the number of penguins, you have to combine the two together. We have some being born, adding. You have some being dying, that's subtracting. All you need to do is B of 0 minus D of 0.
Is that really it? I'm so sorry.
No, but do you make sense?
Yeah.
When you have an in-out problem, birth in, death out, kind of, right? You have to subtract the two to get the total in. Now, Maggie, you said to look at letter D. Integration as net change was letter B. Anyway, this one.
Is this like a sign chart?
Sign chart for which one? Number 2? Let me see. Okay. To the nearest whole number, find the absolute min. Wait, hold on. EBT, absolute extrema, will occur at critical numbers or endpoints. I have to test it in a table of the original. So, right now, I need to test 0, I need to test 40, and I need to test, I need critical numbers. Critical numbers of the penguins, not the born, not the death, but all together. I need to figure out, well, critical numbers, wouldn't that just be when these two are equal? When the rate, which you did for letter A, is 0. Now, could I graph and find the intersections? Yes. Could I graph the subtraction, find the zeros? Yes. And I'm going to end up with T equals. People who solved it, do you have any T's for me? Go team. A and B. Find A, find B. What are we supposed to be doing to test for the absolute highest or lowest?
How high is your Y?
How high is your Y? Well, wait, I need to, P. Ha! I want P of T. What's P of 0? I think they told me. 100,000. P of 40, I think you guys had to find earlier, right?
I did, but I found it wrong. So Missy, if actually on the actual exam, if I get a different P of 40 in like
Yeah,
one,
you're good.
I still get the point later in the question, right?
Yes. So if you plug in the wrong, yeah. It's D of T.
Yeah.
You're doing like a little integration as net change. How are you going to find P of A? Well, you're going to do P of A is equal to P of 0 plus the integral from 0 to A of B of T minus D of T. You have to do these little integrations and net changes, and then what are you going to do? The highest one wins the absolute max, and the lowest one wins the absolute min. Does that make sense?
I knew how high was your Y, but I did not find the critical number.
But that makes sense? Graph the B minus the D, find the zeros. I would say that because otherwise this might be, look at this 1,000 and this 250. This would be a case where if you tried to graph the two and find the intersections, your window is going to be a horrendous mess. Okay, Any other questions on 2013? We've done 2, we've done 3, we've done 4, we've done a little bit of 5. 6, number what? A and B. Oh, I love A because it says what? Tangent line. I love tangent lines because all I need is y minus at. F of 2 equals f prime of 2 times x minus 2. Some of you get confused by the 1.8. He comes in later. This is my A. Go pick out. -8 should go there. Pick out stuff like f prime slope. Well, kind of. A little implicit, but that's okay. Plugging in, I'd have 3 times, well, the x is 2 when the y is -8. There's my tangent line. But wait, how do I use this?
You get it all set up and then you plug your
I get it all set up, and then I steal my 1.8 and I say, haha, 1.8 minus 2. My 3 times 2 squared all over -8. Careful. Approximate. F of 1.8, which is approximate of my y. I need to add this to the other side. Then I can box it. I need to get him over. Then the y is approximating the function value. Now, hold on. We had a question on B. That was A, though. I love tangent lines. Just don't be confused. Yeah, it was, because what was it? Separation of variables. How do you start? I up here, everyone. How do you start when it says find given, multiply the dx? Now, who does not belong? Multiply the dx, move the y. Oh, if you had just started there, how many points could you hopefully get? Point for the separation, point for the left side, point for the right side, point for the plus c, point for plugging in the particular initial condition, whatever, and point for getting y by itself. So many points. Last year, I can almost guarantee that my BC kid who did not get a 5 was because she messed up this FRQ, and she figured it out later. It was like, oh! I was like, no. Oh, it was so painful. So painful. So painful. Because for a BC kid to miss this one, ah. Anyway, so if they can do it, you can do it too. Don't mess it up. Multiply the dx. They can give you funny stuff about bananas or potatoes or snow or bicycling or gravel or, okay? Doesn't matter. Huh? I could almost guarantee that if she got all those points, because she just slaughtered the FRQ as a result of not reading it correctly. And you guys saw the ranges. I like that one probably would have bumped her to a 5. I can almost guarantee it. She was, yeah. Coming back. Katrina hasn't taken her AP yet. Wait, coming back. BC kid from last year. Anyway, kiddos, do we know what to do now? Hopefully, right? What are you going to do with this guy? Now, it's up to you. You can plug in now, then get the C, then be careful. Or you could get the Y by itself, then plug in, then get the C, and then be done. It's up to you. What would you guys naturally do? Plug in now, Y by itself. So multiply by 2, multiply by 2. Y squared is equal to, those two just reduce, 2x cubed. You guys have probably absorbed the 2, right? If you're not plugging in yet, you're allowed to absorb. Have plugged in, no more absorption. Coming back, I can say y is equal to plus or minus the square root of, now, kids miss this part right here. Yeah, they plug in. Yeah, they figure out C. So go ahead and say y is equal to plus or minus the square root of, a lot of kids don't even think about the plus or minus, 2 cubed plus C. They say square both sides, 64 is equal to, that's 8 and 2 is 16 plus C. C is equal to 64 minus 16. You can leave it like that. You can leave it like that. Or you can simplify. Oh, I squared both sides, sorry. So my square root disappeared. That's why I got here. Then they say, okay, whew, I'm not going to miss this point. I know I'm supposed to rewrite the whole equation with the C plugged in. And then they write this. Why is this, even if they don't simplify? So let's not say they made a mistake. They didn't make it 49 or something instead of 48. They wrote that. They were good. Why is this wrong? In order for the 8 to be negative, which square root did you have to choose? In order for the 8 to be negative, you had to choose the negative. So the negative was the one you needed to put. Dun, 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 dun. How many points? 6, 5, 7? 6 points. Could 6 points have bumped you from one letter to the next? Some of you, probably most of you. Any other questions? 2017. I think that's the end of 2013. 2017. Any questions? I can go through the FRQs real quick. We have 3 minutes. In 2017, we had the particle. We had the water tank. Yeah. This one?
Yeah, for A, I had the right value, but I put acceleration is velocity delta time. Motivation was, even though I had the right value.
You got to be careful with your math because your math all has to line up. So acceleration, you got to put v prime. Or x. Got to be careful. Got to be careful. I know. Any other questions? We have the velocity-ish one, then we had the water tank-ish one. I think we looked at that one yesterday. I talked more about the water tank one in period 1 for some reason today. I don't know if we didn't talk about it yesterday. It was nasty. Then we had the... Ooh, hey! No, you can do it! Because... Hey, some of you were really scared about this one a second ago in the 2013.
But now we know what to do with that.
What do you do when you're trying to find... Wait. Use your forever card. Average rate of change. Isn't that G of B minus G of A all over B minus A?
Yeah, but it didn't work.
It does work, because check it. Wouldn't I have to multiply that by G of 5? Isn't that the integral from 1 to 5? And then G of negative 5, isn't that the integral from 1 to negative 5? Now, some of you might have realized that you could have done the average rate of change of G by doing the average value of F. You have to plug in wherever it goes. But you could change the 1 to negative 5 by...
Negative.
Yeah.
Sorry.
No, that's totally legal, right? And if you notice, isn't that just... That's everybody. It's just the whole shebang. The whole shebang? Yeah. So do this area as a negative, that area as a negative. P.S. That's a quarter circle.
Oh, the other one's a triangle.
That's a triangle.
Got it.
That one's a triangle. That one's a triangle. Well, you could do trapezoid. I don't know. My brain likes triangle, rectangle a lot better.
Yeah, but that was the ugliest shape.
Up to you. So that'd be a negative, that'd be a negative, that'd be a negative, that'd be a positive, that'd be a positive. I just and then 1 over that, and then except
Wait,
no
what
units.
would you do?
Oh,
How would you simplify the integral?
I'd have to find all this. No, I'd go finding all my areas.
Okay. So you would do it geometrically?
You have to. There's no other way. Because I don't have a function to put in.
No.
So I have to do my negative 1/2 base 3 height 4. Then I'd have a negative 1/4 pi r is 2. Then I'd have a negative 1/2. Make sure my negative is there. 1 times 2. Then I have a positive 2 times 4.
And then just a base.
And then a positive 2 and 4.
When you have to subtract that from the other.
Stick it to the man.
Oh, you factor that.
Bye, guys. Looks like it. Hold on, let me check.